Okay, hello everyone, welcome to the new section on deep learning. So in the previous 2 weeks, we have provided with a basic background knowledge already. We talk about what are the machine learning basics we need to know about learning a model, and we also talk about the optimization algorithms we can use to train a model, right? So from this week, we'll finally move to deep learning for you. And in this lecture, we plan to provide you with some basic information about deep learning models, what is deep learning, why we need to have deep learning, as well as the history of deep learning. So here is outline for today's lecture. In the very beginning, we will discuss what is deep learning. Because we know already what is machine learning, right? Then you may also wonder what is deep learning and what's the difference or the relationships between machine learning and deep learning. We'll provide you with this information for you, and then we can provide you a very brief history of deep learning for you and what makes deep learning can work nowadays. And then we talk about the artificial neural models, which is the basic unit for building very complex deep learning models to be introduced in the following lectures. And then we discuss about hidden layers as well as multi-layer perceptual model, which will be the very basic deep learning model that can be used for embedding of the inputs as well as for many of the tasks. Finally, we will discuss about the error backpropagation algorithm, which will be very crucial and important algorithm in deep learning. Because nowadays, almost all the deep learning models, their training still rely on the error backpropagation algorithm right now. This error propagation algorithm is based on the gradient descent algorithm we learned from the last lectures. However, for the error propagation algorithm, they provide us with a way to utilize the intermediate results in the calculation of the gradients to be used from the upper layers to the lower layers. In other words, the learning process will be much faster and efficient than the vanilla or than the raw gradient descent algorithms. Okay, so we discuss them one by one for you in the following pages. So you may wonder what is the relationship between machine learning, deep learning, as well as artificial intelligence. Here we provide you a very basic diagram to show their relationships. So machine learning is one of the key subjects studied inside the AI or the artificial intelligence. Besides machine learning, we also have many other subjects to be studied in artificial intelligence. For example, we also study this natural language processing, we also study the computer vision, as well as many other areas, right? So machine learning is also studied in many areas besides artificial intelligence. We also study machine learning by the statistical people from other perspectives, right? So machine learning can be studied in many different perspectives, and inside we have one key part which will be about deep learning. So normally you can see in this way, deep learning is one category of the algorithm covered inside machine learning, and machine learning is one of the key subjects studied inside AI or the artificial intelligence. And you may also wonder, we have the classic machine learning already, why do we still need to have the deep learning? So according to our previous discussions, right, we know when we have some data inputs, we can build a machine learning model to do the classification, to do the regression, to do the clustering for us, right? So for example, in this page, we have an image about dog, right? And we want to build a model to recognize this image is about dog. According to our previous knowledge or discussions, we know that given the data inputs, we have to do some feature extractions in machine learning models or in the machine learning solutions, right? So given the dog input image, and we can extract some features manually, this may require some domain knowledge or domain experts, right? So by the domain experts, we can design some features. Now, given the dog image, we can recognize how many eyes this image may have, right? As well as nose corner, as well as further corner, as well as some other features. So by extracting many different kinds of features which are designed by some domain experts based on domain knowledge, we can transform this input image into a feature vector, right? By their values. We can have a feature vector about this dog or about this image. Then based on this feature vectors, we can further build a machine learning model, right? And this machine learning model will be a mapping from the feature space to the label space, right? And the machine learning will, provide a mapping from the inputs to the outputs. So according to the distribution of the feature vectors in the feature space, we can draw the decision boundary, right, to partition the data instances into different classes. For example, for this one, we can classify this input image is about dog according to the features we extract. So you can see in the process of the classic machine learning, this kind of algorithms, the features we extract from the image plays a very crucial role, right? Because all the following classification or regression, they are all rely on the features we extract. However, do we have any good ways to design the features? The answer is no. We have to rely on some domain knowledge, and we rely on some domain experts. So if we don't have the domain knowledge or domain experts, then the feature extraction will be very costly, right? Because we have no way to design the features by ourselves. Also, for many of the domains, the feature extraction process is also very costly because we have to run some of the algorithm to help us decide the features. Given the input image, we have to rely on some human beings to recognize how many eyes we have and what are the corner of the nose and what are the further corner of the dog, which also rely on some human efforts for extracting these features. So if these features are meaningful or also useful, then we can design the models, with the machine learning techniques for classify the input data. However, if these features are useless, then the models we build will be useless as well, right? So classic machine learning relies on the manual feature design as well as manual feature extraction, so which will be very important for the performance of the model. So actually nowadays, this kind of way for the machine learning algorithm, we also encounter many challenges, especially for some domains. So for example, in this page, we provide the image of a dog. And according to our feature, we can recognize this should be a dog image. And how about these ones? Right? And we can see that, if we mix the dog image together with the cupcakes together, right? Then, according to the features we designed by the domain experts, sometimes this feature will be useless, right? Because this domain experts will not recognize we can have something else which is so similar to the dogs, like the cupcakes. Even for the human beings, it will be very difficult for us to recognize what are dogs, what are the cupcakes, right? Which is the main challenge we are facing in many areas when applying machine learning models to the task. And we are calling for a new category of models which don't rely on the domain experts for the feature extraction. And we have to build a model which can extract the features by itself instead. And these features will be more robust than the classic machine learning features designed by the domain experts, right? Okay, so this is the reason why we need to have the deep learning models which can design the features by itself. And then you may wonder, what is deep learning model and what's the difference of the deep learning versus classic machine learning? Before we mentioned that the machine learning models will rely on the feature extraction and then for model building, right? In other words, these two parts together, the feature extraction as well as the machine learning model, they together will decide the performance of the task or of the solution we provide, right? So we also mentioned that the feature extraction process, this part will be very weak or fragile, right? Because some of the features will be useless, and the domain experts cannot consider many of the cases. And we are calling for a new way to extract these features for us, and which will be much more robust and also consider many of the cases depending on the data we have, right? So therefore, we have a deep learning model. The deep learning model is very similar to the machine learning model. However, the deep learning model will integrate the feature extraction step as well as the machine learning model, these two parts into one model instead. In other words, for deep learning, we don't require the manual feature extraction and design anymore. And all these two steps, the feature extraction design as well as the machine learning model building, these two parts will be integrated into one single model instead. In other words, in the deep learning model, given the data inputs, we feed the inputs to the model can learn the features by itself as hidden layers. So these are inputs, we can serialize this matrix of the image into a vector and feed it into the input layers of the deep learning model. And then this model will feed these inputs to the following layers, like hidden layer 1, hidden layer 2, hidden layer 3. And we can learn the features layer by layer. For each layer, we will learn some hidden representation of the inputs, which is more like the hidden features. We can get some hidden features layer by layer, and these hidden features will be projected to the outputs. And based on this output, we can further categorize the outputs into the labels for us. You can see the difference, right? So we still rely on the same input and output. However, the main thing or main difference between the machine learning versus deep learning is that deep learning don't require any manual effort on the feature designing and weather extraction anymore. It will integrate the feature extraction step together with the machine learning model step together into one single model. This model will do all the things, do the feature extraction learning, as well as do the classification task. So this is the main idea about deep learning. This deep learning will learn the features by itself, do the feature extraction by itself, via the hidden layers, layer by layer. And this representation of the features we learn by the hidden layers is more robust in many of the cases, and we can adjust these features learned by the model according to the data inputs we have. So just for the image we showed before, right? If we have data inputs like this, it will not work well for the classic machine learning rely on the manual feature extraction as well designing. However, if we feed this kind of data to the deep learning model, and we can provide the model with some of the label information or supervision information. Given some instances, we can label this one as a dog, this one as a cupcake. If so, then we can feed this data like this into deep learning model. This model will extract some meaningful features to differentiate the dogs from the cupcakes. So it will work well for addressing the dilemma we are facing here for this kind of data sets with deep learning model. So by now, I hope you understand me why we need to have deep learning model and what's the difference between deep learning model versus the classic machine learning models.